Hi everyone, it's Miss Moncrief again, back with another video. Today we're talking about the Midsegments Theorem. Our lesson objective for today is students will be able to identify midsegments and use the Midsegment Theorem to solve problems involving triangles. All right, so Midsegments Theorem. A midsegment connects the midpoint of one side of a triangle to the midpoint on another side. So let's say we start on this side here. There's my midpoint. Put a point there and label it midpoint. And then we're going to pick another side of the triangle. Label a midpoint right there. Connect those 2 points together. This line segment here is called a midsegment. That is a midsegment. Now, there are 3 different ways you could draw this. That's just one, okay? But really there's 3. Every triangle has 3 midsegments. The midsegment is parallel to the third side of the triangle. So on this triangle, let's just draw the midsegment again. There's my midsegment. And if you see here, these 2 sides, this side, and well, not these 2 sides, the midsegment and the third side, they're parallel to each other. And remember, we denote that they're parallel by drawing these 2 triangles. Next thing, the midsegment is 1/2 the length of the side it is parallel to. So again, here's our midsegment. If the length of this side down here is 10, and the midsegment is 1/2 the length of the side it's parallel to, how much would the midsegment be? It would be 5, okay? So you could think of it both ways. You could think of it as the midsegment, you would double it to get the length of the parallel side, or you would think of it as, write that down, double, or you could start with the parallel side and cut it in half. So it works both ways. This right here is really the central point of the midsegment theorem. And then lastly here, I'm gonna switch the colors so that you can see corresponding angles. Are congruent. So let's put back in our midsegment. If we think of this as a transversal, then we're gonna see here that this angle and this angle are corresponding angles, so they're congruent. Or you could, let me get another color. You could think of this side here as a transversal, and in that case, these 2 angles here would be corresponding angles. But in any case, they're congruent. So if this angle measures 31 degrees, this one has to also be 31 degrees, okay? If the beige one measured 45 degrees, this other one has to also be 45 degrees, okay? So let's put this into practice. Example 1, name the segment parallel to a given segment. If you have a highlighter at home, I suggest you highlight it. Draw this picture, copy this picture in your journal, and copy down these 3 examples. 1, 2, 3. So I like to highlight my given information, or what I'm looking for. It's looking for XZ. So here's segment XZ. Which segment is parallel to XZ? That would be this one here. That's that third side, BC. So my answer for this one is going to be BC, line segment BC. Now I'm looking for something parallel to AC. Here's AC here, and that would be the parallel side. So that would be XY. And number 3, I am looking for something parallel to ZY. ZY is here. So the parallel segment would be AB. That's all that one's asking for. It's just practice, just to make sure you know when you're given all the sides in the triangle, you gotta know which ones pair together, which ones can help you get the other ones. That was the purpose of that exercise. Example 2, now we're gonna actually use the theorem. Find the length of the missing segment. So they give us this drawing here. You can go ahead and copy that into your notes. And then these are the questions. So if DE equals 2.5, I'm going to label my given information, 2.5, find AC. What is the length of AC? Well, we know that the midsegment is half of the length of the parallel side. So if the midsegment is 2.5, remember we said if we're starting with this, we double it. So if you double 2.5, you're going to get 5. So the answer for this one is going to be 5. AC would have to be 5. If you cut AC in half, you cut 5 in half, you get 2.5. Again, it works both ways. I'm going to erase this so that I can make it clear for you for the next one. If AC equals 20, what is DE? So again, we're starting with the big one this time. So to get something smaller, we're gonna cut it in half. That's how I could think of it. So what's half of 20? Half of 20 is 10, okay? Next one, if AC equals 9, how much is DE? Well, we're going from the big to the small, so we're gonna cut it in half. Half of 9 is 4.5. Last one for this part, if DE equals 4, how much is AC? Well, we're doubling it. We're going from something small to something big. So AC would be 8. In this one here, we have a little lake. Sorry about that. We have a little lake. The parallel side is the length of the lake, and they drew their midsegment for you. The midsegment is 6.5. So to get the missing length here, we're going from something big to we're going from the small midsegment to the big parallel side. So to make something bigger, we would double it. If you double 6.5, you're gonna get 13 miles. Half of 13 is 6.5, it works both ways. Example 3. Points M, N, and P are the midpoints of the sides of triangle QRS. QR equals 30. So QR equals 30. SQ equals 18. MP equals 5.5. Angle RMN equals 41 degrees. And angle NSP equals 38 degrees. Okay. Find NP. So find NP. NP runs parallel to QR, and we know that QR is 30. So half of 30 is going to be 15. My answer for NP is 15. Next question, find MN. MN runs parallel to QS, or SQ as they call it. QS, the measure of QS is 18. We're looking for the midsegment, which is smaller, so we're gonna cut 18 in half, and we're gonna get 9. Find, next question, find RS. RS is here, and RS is parallel to MP. MP is 5.5, so we're gonna double 5.5, and that's going to give me 11. So the length of line segment RS is 11. Next one, these are the angles now. Find the measure of angle RQS. Let me get a different color highlighter. Okay. Let's see the screen. Measure of angle RQS. RQS is right here. That's right there. That one is congruent to RMN because they're corresponding angles. They're both in the top right. Okay. If we were to make these into 2 parallel lines, and that would be the transversal. Sorry about that. 2 parallel lines. That's my transversal. They're both in the top right, so they're congruent. So therefore, this is also going to be 41 degrees. And lastly, I'm looking for the measure of RNM, in this order, RNM. So I'm looking for right there. Again, these are two parallel lines, and now this is the transversal. So these two correspond, they're both in the top left. So if this one is 38, if NSP, this one here is 38, that was given, then this other one that I'm looking for, RNM, is gonna also be 38 degrees. So that's basically how you use the mid-segment theorem. Hope you learned something today. Have a good one.